Here comes the next and most important chapter of our subject, that is something called steady state AC circuit analysis. Now, as I said, before we get into this details, let me quickly give you what exactly are we going to learn in this particular chapter. Again, let me divide this into 4 parts. What do you mean by a word called analysis? Analysis means what? It's a study. What do you mean by circuit? Interconnection of several varieties of elements, I call it as a circuit. If you feed it with DC supply, DC circuit, AC supply, AC circuit. So, what exactly are we going to learn in this chapter is we are going to analyze those particular circuits which are fed with AC supply during which condition? Steady state condition. Already we have seen steady state DC circuit analysis. Here, the same circuits we are going to see, but this time we are feeding it with AC supply and we are going to analyze. That's the difference between second chapter and fourth chapter. Alright. Now, as I've mentioned previously, the phenomena of electricity has started somewhere in the early of 18th century. It took several years to bring this electricity into a proper shape, and almost all somewhere around 1870, 1872, this DC supply came into a proper shape, and finally, as you know, DC supply was found. I hope you all are aware that initially DC supply was found and later on AC supply was found. Now, as soon as this DC supply was found, here comes one of the greatest inventions ever happened in the history, and that is invention of bulb. This invention of bulb happened somewhere around 1873 to 1875. This was, as you all are aware, invented by Thomas Alva Edison. Now, as soon as this bulb was invented, people were thrilled to see this kind of invention. Why? Because in olden days, the source of light used to be either the sunlight or the gas lamps or the candles or etc. But as soon as the bulb was invented, people were really thrilled to have light during darkness, that is, I mean during nights also. So therefore, as soon as this bulb was invented, and then afterwards the motors, DC motors has also come into picture, and looking at all these things, the demand for DC supply was also increasing day by day, and things were going on fine. But exactly, I think it's somewhere around 1877 or 1878. A big war happened between two groups. One group was saying that DC is the best, and the other group was saying that AC is the best. And finally, what do you think? Who won the war? AC supply has won the war. Now here comes the next big question. The one who was supporting for DC supply was Thomas Alva Edison, and here comes the one who was supporting for AC supply was the great man, somebody called Nikola Tesla. Okay. He's the man behind, I can say, a sinusoidal wave. He's the man behind something called rotating magnetic field. He's the man behind something called alternating current. Now, so finally, what do you think? Who won the war? AC supply has won the war. So, now here comes the next big question. Why? Between DC and AC, why only AC supply has won the war? There are several drawbacks in DC supply, and those drawbacks has been overcome in AC supply. So, before we get into this chapter, we should answer two questions. I can say $2 million questions. After answering these two questions only, we are eligible to enter into this chapter, in which the first and foremost question is, between AC and DC, why only AC supply? Whole world is running behind AC supply. There are a lot of advantages of AC supply. So, what are those advantages? Why only AC? Why not DC? This is the first question that you should understand. And here comes the next big question. What do you mean by alternating supply or alternating current? Alternating current means with respect to time, its magnitude should change. Not only magnitude, for every half cycle, its polarity also should change. Only if magnitude is changing, I don't call it as alternating current. I can call it as a pulsating DC only. Okay. So, the moment, what do you mean by alternating current? As I said, so as time proceeds, for every instant of time, its magnitude has to change, and for every half cycle, its polarity also has to change. For example, I can say this is an alternating current. This is an alternating current. This is an alternating current. Out of different alternating currents, the moment I say alternating current, which signal will come into your mind? Sinusoidal signal. So, here comes the second question. Out of all alternating currents, why only sine wave? Why not triangular? Why not rectangular? Why not trapezoidal? Why not quadrilateral? Why not something else? Two questions, as I said. First question, between AC and DC, why only AC? Second question, out of different alternating quantities, why only a sinusoidal quantity? Why not something else? After answering these two questions, then when this AC supply is connected to your circuits, your resistor, how exactly a resistor is going to behave? Inductor, how is it going to behave? Capacitor, how is it going to behave? And initially we are going to connect this AC supply for single elements. Then afterwards, in the practical world, you cannot expect only single element to be in the circuit. You will have the combinations like RL, RC, RLC, right? So then we are going to take these combinations like RL, RC, RLC in series parallel connections and feed it with AC supply, that too sinusoidal AC supply, and observe we are going to observe what exactly going to happen with these circuits or elements, right? So initially, as I said, we will be seeing steady state DC circuit analysis. In this chapter, we are going to take the same circuits, same elements, but this time we are going to feed it with AC supply, that too sinusoidal AC supply. Now, if I say AC supply, take it as granted that it is sinusoidal AC supply only until and unless I specially mention a triangular, rectangular, trapezoidal, etc. Right? So, that's about something called steady state AC circuit analysis.